Hi, it's Sukrit from STEM Coder, and in today's video we're going to look back at all the derivatives we learned in this lesson. Without further ado, let's get started. Up first are the simplest derivatives. The derivative with respect to x of a constant c is just 0, and the derivative with respect to x of a constant a times x is just equal to a. Next up is the power rule. The derivative with respect to x of x to the power of some real number n is equal to n times x to the power of n minus 1. And we have the scalar multiplication rule. The derivative with respect to x of a times a function f of x is equal to a times the derivative of that function f of x, f prime of x. Next up is the sum rule. The derivative of f of x plus g of x is equal to f prime of x plus g prime of x. And next is the product rule, d over dx of f of x times g of x. So the product of two functions, f of x and g of x, is equal to f prime of x times g of x plus f of x times g prime of x. Up next is the quotient rule. The derivative with respect to x of a function f of x divided by a function g of x is equal to f prime of x times g of x minus f of x times g prime of x divided by g of x squared. Up next is the reciprocal rule. The derivative with respect to x of the reciprocal of a function f of x that's equal to 1 divided by f of x is equal to the negative of f prime of x divided by f of x squared. Up next we have our trig functions. The derivative of sine of x is cosine of x, and the derivative of cosine of x is equal to negative sine of x. Now before we finish, you should also understand the limit definition of a derivative. We can define the derivative with respect to x of a function f of x as follows. The limit as h goes to 0 of f of x plus h minus f of x divided by h. And finally, in the last video we learned that differentiability implies continuity. So if a function is differentiable at a point, it also has to be continuous at that point. I hope you found this quick review helpful, and I look forward to seeing you in our next lesson where we're going to go over intermediate derivatives. They are going to be more complex, and we're going to use a lot of the concepts we learned in this lesson.